This is the HJ-580LA right next to a penny. It has a DA14580, which is one of the world's smallest Bluetooth chips, and it's on this little board that contains some extra components. And this one is programmable, so whenever you get the HJ-580LA, it's not programmed, so it's not pre-programmed with any sort of program on it, and so it needs to be programmed so that you can do whatever you would like with it. What I'm planning on doing with this is getting it to connect up with a phone so that you can transmit back and forth serial messages. And now this is the HJ-580X. Now this one is pre-programmed, and I actually haven't really figured out exactly how to use it yet. I think what you need to do with this one is you have to have two of these, and then they transmit back and forth between the two, and you can connect up to the pins to receive data from it and send data to it, which sends back and forth between the two. I believe that's how you use the HJ-580X, but I could be wrong. We're not going to mess with this one today. We're going to mess with the HJ-580LA, and we're going to get this thing programmed. I also have this breakout board that I ordered, which makes it easy to connect up to the pins after it's soldered on. If you don't have a breakout board, I also did make my own breakout board for one of them, so that's also a possibility. I just got these tiny wires that I soldered onto each little point. That did take a bit of time, but I did get that to work as well. But this is definitely a lot cleaner. The final result looks something like this, and then you can attach these pins onto it and easily connect up and do whatever you'd like with it. So I'm going to show you how to make one of these modules, as well as put together one of these in a time-lapse video. Okay, now let's start connecting up the circuit. Make sure you have your wires connected onto the module, and we're going to be just adding this onto the breadboard, one wire at a time in this direction, going this way, and then this way, and then this way. all lined up on the board, starting with this red wire. And by the way, these pinouts align directly with the pinouts on the Bluetooth module, so you don't have to worry about the circuit being swapped up in this board. So let's start by attaching the red wire. Okay, now we have all these wires connected up in order, and so we can easily access each whichever wire, whichever output we need. So now let's start connecting up the power source. You're going to need a USB to UART TTL adapter, and this provides a power output with ground and power here, as well as TX and RX for transmitting and receiving data. And so we can start by connecting up power. Power is the red wire, so we connect red onto the power rail, and then the ground wire onto the ground rail. And so this will provide us enough power to power up the device. Now we can connect the power up to the device itself from the power rail. This power goes to VCC on the device, which is the second pin from the right in the middle. And then we can also connect up the ground pin from the power rail, which is the first pin on the right in the middle. Okay, so now we have power to the Bluetooth device. Now we can connect up the RX and TX. Now the green is for transmitting, so we're going to connect that up to the RX on the Bluetooth device, because we're transmitting here and the Bluetooth device needs to receive it. So TX goes to RX, and RX is the second pin on this device, on the right group, second pin. And then we need to have the receive on the USB to TTY on the transmit, so that we can receive data from the Bluetooth device that is being transmitted. Later on, after we have a working program programmed onto the Bluetooth chip, you're going to need to also supply a programming voltage. Now this programming voltage is a voltage of 6.6 to 6.8 volts max. And so the programming voltage goes on VPP, which is the third pin on the very right group, starting from the inside here, 1, 2, and 3. So what you want to do is add a place where you can attach a source for voltage that can go onto the VPP, and then also connect up to the ground power rail. Now what I'm doing here is actually, I have a connector for a 9-volt battery. Now this 9-volt battery has been worn out to the point where it's at around 6.7 to 6.8 volts. So right here I have a 9-volt battery that I can show you. It should be about 6.8 volts. Okay, so it's at 7, so I could wear that down some more, but we won't be using that until we have a working program on here that will run fine. So you can just leave this off for now until you need to burn the program onto the chip. So that's about all the connections we need to have set up for now. So now we can go on to getting the programming environment set up. The first thing to do when setting up the environment to program to these Bluetooth devices is download their SDK, which is Smart Snippets Studio. And this can be found on the Dialog Semiconductor website. And you're going to need to make an account, and I believe they also have to accept your account creation, which can take a couple days or so. And then after that, you should be able to just download Smart Snippets Studio. The problem is you're also going to need to do another step, because we're going to need to download other things, where you need to click on this restricted button and then agree to the license agreement, and then it will also take a couple of days, I believe, for them to accept your request so that you can download the files off their website. I don't think you have to do that for the Smart Snippets Studio. The thing is, I've done this before, so I don't know if I clicked the restricted button or not. But right here, you're going to download Smart Snippets Studio for Windows OS and click on the zip file, and it will start downloading. This is a gigabyte file, so it's going to take a little bit of time. And then also, let's go ahead and download another file while we're at the download page. Click on the reference designs and software examples, and we're going to need to download the Dialog Serial Port Service source code, and this is the project that allows for connection between your phone and the Bluetooth device and sending messages between the two. So click on the restricted button, go down and agree to the license agreement, click submit, and then it says you've been granted access. Now the thing is, I've done this before, but they changed their license agreement, and so I had to do that again right now. But for you, I believe you're going to have to wait some time until you can download it. They're going to have to accept your request. So, reference design and software examples, and I can download the Dialog Serial Port Service source code. I'm going to click on that, click on the zip file, and that will download as well. Now that the two files are downloaded, we can unzip both of them. So go to your downloads folder, and we can go ahead and extract all with both of the files. The 1 gig one will take a while. Now we have Smart Snippets downloaded and extracted, and we can run the installer. And we can go through the steps to install. Okay, and now Smart Snippets Studio has finished, and we can now launch it. Press OK. When we're going through the configuration, make sure you choose Treat as DA14580X instead of 1468. Now what we're going to need to do here is actually download something called UVision IDE, Keel for ARM embedded processors. So let's go click Next. JLink software package components version 5.12 cannot be found. We can just say install the required version. That part's simple enough. Okay, so it's installed. We can click Next. So we're going to need to download the Keel UVision software. So this link for some reason isn't working, so I'm going to have to type it in. And I have it right here. And then you're going to have to fill out some information before you can download it. For the bottom part of the form, you can say I'm using devices from others, since Dialog isn't listed. And then this thing runs a Cortex M0 processor, an ARM Cortex M0, so choose that. And then by ticking this box, you've read privacy policy, then submit. Okay, and now it comes up with the area where you can download the MDK523.exe file. And this is 720 megabytes, take about 5 minutes. Now we can go through the setup. Okay, and click next, terms and service, path, and then it wants your information. After you've entered in the information, it will begin installing. Alright, and we can choose install for the serial bus driver. And it looks like it has finished successfully. So click finish, QPEC installer, press OK. Alright, looks like everything is good here. And it looks like it's doing some stuff down here. So I'm just going to let this run off to the side. And we'll go along and finish the Smart Snippets setup. So as I mentioned, you basically just want this Keel V5 folder, and then press finish. And now everything should be set up here. So now we can start with messing with the actual project, and we can compile the DSPS project so that we can later download it onto the device and then test it. So from the downloads and what we've extracted, go into the DSPS folder, click again onto the next folder, click the next folder, click projects, click target apps, DSPS, and then SPS underscore device, and then Keel 5, that's the latest version, and then press on this project. Now it's going to open in the UVision software. So when you first open the project, we're going to have to change a few files to make sure everything's going to work properly on the specific device layout that we have. So under the user underscore config folder, let's start out by opening up the user underscore config.h file, and in here scroll down until you see this static constant sleep state app default sleep mode, and change it from arch underscore ext underscore sleep underscore on, change it from that to arch underscore sleep underscore off. Now what we're needing to do here is disable the sleep mode that is set on this device, because you need to have some sort of hardware setup so that it can get out of sleep mode, which we don't have set up. It could be possible to still do this with this hardware that we have, but that would require some additional things to do. So in addition to this file, we can scroll down and you'll see user underscore device underscore name. Now this is what your Bluetooth device will show up as whenever you are looking for it on your phone. So it will show up as dialog underscore SPS or dash SPS, and you can change this to whatever you want. So I could change it to my blue device or my BT device. And I don't think it matters to have spaces, so this should be fine. Now, also we're going to need to change something in this DA14580 underscore config underscore basic.h. And here it's defining mim map external sleep. All we have to do is, so scroll down until you see that, all you have to do is change that to undef or undefined. And that's also something that needs to be done to disable the sleep mode. And now go from that same folder, go to user underscore peripheral underscore setup.h, and then in here where it's defining hardware flow control and undefining software flow control. What we want to do is swap that around. Config software flow control and undefine hardware flow control. And then we can save this, or go to File, Save All, and now we can build this project. So go into Project, and then Build Target. And now you should see it going through the build process. Okay, and it looks like it has finished building. So now what we can do is open up Smart Snippets Studio, choose the Smart Snippets toolbox, and make sure that you have your USB to TTY cable plugged in, and make sure you have it set up correctly. If you don't know if you have it set up, correctly, go into the Device Manager, and you should see under Ports your USB to serial COM port that's connected, and there shouldn't be any warning next to it. So what you want to do is press the New button, and we're going to call this Serial Service, and then you can press Save. Now this just makes a profile for whenever we are opening up this project. So Serial Service, choose your COM port. Make sure this is on UART only if you're using UART. Could use JTAG, but I haven't really needed to. Now make sure you choose the DA14580-01. Now press the Open button, and then it will open up our workspace to where we can do various things such as boot into it. So this has a power profile. You're not going to be able to do any of that with the setup that we have. You're not going to be able to use any of that tools. So what we want to do right here is press on the booter and board setup. And we don't really need to do anything to the board setup, thankfully. But what we really need over here is this booter tab. And this allows you to open up and send a hex file onto the Bluetooth device without actually flashing it to the chip. It basically just puts it into RAM and then runs it. As soon as it loses power, it no longer can run the program, and you'll have to download it again. So for the sake of testing to make sure that the program works, press the Browse button. Now go into your folder wherever the project is. Mine's still in the Downloads folder. Then go into DSPS, same project folder, Target Apps, DSPS, and then SPS Device, kill 5, and now you'll see this out_580 folder. And then when you go in there, you'll see the hex file that we exported, that we built. And then press Open. Now this can be a little bit difficult to get this to download. Sometimes it has issues. Sometimes you can get it to work on the first try. You really should disconnect the power whenever you press the download button, and it can trigger it to start downloading to the board. Now what I've tended to do, see right here it's not working, there should be a reset button. So there's no really reset button, but like I've talked about, whenever you're downloading it, you could try disconnecting VCC pin or shorting ground and VCC right after you click the download button for just a tiny moment. Or what I tend to do is disconnect the device, and it might have it will have this connection lost button pop up. Press OK. Now connect the device back up real quick. As soon as you connect it, press the download button, and then it will start the download procedure, and hopefully it will download. And here you can see it says it has successfully downloaded firmware file to the board. So what it does is whenever the device starts up, it will indicate that it's ready to download something to it. But I guess after a certain amount of time, it doesn't do that. So this is how I usually do it to get it to download to the board. Now what you want to do is go on your phone so we can test the device out. Now first of all, you should be able to just simply from Bluetooth, should be able to scan and see it as an available device. Here you can see it says my BT device. And then also, we need to go to the Play Store and download an app. Just go and type in DSPS Dialog Semiconductor, and it will come up with this DSPS app, and this is specifically made for this project. So once you have the app, open that up, and now it's going to search for the devices, and then you can see it shows the my BT device, so you can click on that, and then you should need to wait till this turns green. Sometimes it has some sort of connection problem. You can just go back and open it up again until you see that that turns green. And now you should be able to send text back and forth from the computer to your phone and from your phone to the computer, both ways. So I'm going to send a message from the computer. I'm going to type in hello and then enter, and you can see that it shows hello on the phone. And then I could type in something from here, goodbye, and then press send, and it should show up on the computer. So there are two ways that you can use to test sending messages between the device and your phone and the Bluetooth device. The first way is you could use this default UART terminal. Go into the tools section and you'll find this little terminal button, and that will open this up. Now then you press the start terminal button, and then you can send a message to the device. So for example, hello, and then that would show up on the device. Now the problem is with this setup, I'm trying to send a message back. I'm sending goodbye back to the device, and you can see it actually sends 2 letters at a time. Well, it's not sending 2 letters, it's showing 2 letters at a time. It's actually just a bug with this UART terminal. So I'm not exactly sure what causes that. So you're going to need a third-party software to send and receive messages. Now what I like to do, it's pretty easy since I already have Arduino installed. Now you could try PuTTY or something like that, anything for USB serial console or whatnot. So I already have Arduino installed. So I'm going to open up Arduino, and this has a default, it has a built-in serial monitor. So if you click on tools, make sure COM3 or whatever COM port it is, and choose serial monitor. And then whenever I send goodbye, you can see that the full the full message is being shown, and I sent it multiple times there. And same with sending a message to the Bluetooth device, like hello. And it works as intended. So now that we have it programmed, it's only going to stay in memory for now. So what we want to do is make it a permanent program. Okay, so when we're going to burn the actual image onto the device, we can get it set up on the software real quick. We can click, what we need to do is go to layout and then choose OTP. Now this has everything we need to burn to the device. We're going to be using this OPT image tab as well as this OTP header tab. And you can see what I did, I connected the device up and pressed connect, and then I pressed read, and it it came up with this data here. So this shows you in hex what is actually on your chip, and you can see there's nothing on there right now because there's no program set to load yet. And so what we're going to need to do before we burn a file onto the chip, you need to apply the VPP voltage. So make sure that your power source is from 6.6 to 6.8 volts. You can see mine is at 6.7 about. And we can connect up the power to the VPP. And now we can go on to burning to the device. Alright, so it's about time to burn to the Bluetooth chip. So I'm going to browse to get the firmware file, and I need to go to my downloads again and go into and find the hex file. Projects, target apps, DSPS, SPS device, kill 5, out, and then the hex file. And then press open. Alright, so now we can press connect. And it's showing that starting download procedure. Okay, so I'm going to have to disconnect the USB port in a second after it finishes. I don't want to mess anything up. Okay, so I'm going to disconnect the USB. Now I'm going to reconnect it. I'm going to press the connect button now. It says successfully downloaded firmware to the board. Now this hasn't really burned it yet. So it's connected. Now press the burn button. Are you sure you want to burn with the memory to address blah blah blah? And choose yes. Showing it's connected. Starting reading. Connected to COM port. Successfully opened. Reading has finished. Okay. Now you can see here that this program over here matches the program over here, meaning it's on the chip. But you need to do one more thing. Go into the OPT header, and then application flag 1, choose to yes. Application flag 2, also yes. Now this makes it so it boots up into OPT as soon as you provide power to the device. And as soon as you set these flags, we're going to press connect first, and then I'm going to have to reset. I'm going to have to do this again. I'm going to have to disconnect again. Alright, so I'm going to disconnect and reconnect real quick. I'm going to check the OPT image tab, press connect, and then read to make sure that it's the same program on there. Make sure nothing's changed. Okay, so it looks like everything's good. And then go into the header, and we might have to redo this again, but yes and yes, and then we can press burn. DM length should not be smaller. Do you want to continue anyways? Yes, that is fine. Okay, it shows that it has burned 256 bytes to the address, and so now we can disconnect the OPT or the VPP battery, and we should be set to go. As soon as you provide power to the device, it should boot up into the program that you wrote, or the program, the DSPS program. Alright, so I think everything is working now. We've got the red power disconnected from the Bluetooth device. I'm going to connect it now, and it's going to boot up straight into that program. I'm going to press the scan button on this app again. You can see that my device came up, and I can send and receive messages. So I think I'm going to leave it at that. I could create another video on showing how you can make your own app to send and receive messages over Bluetooth. But right now I'm going to end it right here. Keep in mind also you can extend the antenna on this thing to make it so you can actually have a better antenna. It looks like right here you can add an SMD, probably, yeah, it's an SMD resistor, probably a 10K or something like that. Not exactly sure, but you can make the antenna, you know, and make the range longer and everything. Keep that in mind. And thank you all for watching. Have a great day.